Hey guys, apparently the last recording I had for chapter 16-6 and 16-7, for some reason it just showed me talking. I did it at the school. So I'm redoing it, making sure that you guys see the notes and it's actually completed. Okay. So let's go ahead and let's get this started. So in 16.6, we're talking about geothermal energy. And yeah, there's a lot of potential for it. We can get electricity and heat from it. Environmental impact, not that bad. But again, it depends where it is, so there's a limit as to where we can get it. Excuse me. All right. So, what is geothermal to begin with? If you break down the word geo, it means earth, like geography or geology. Geology is the study of the earth. Okay. Geothermal is heat of the earth, earth heat. Thermal having something to do with heat or temperature. Okay, so when we're looking at geothermal energy, we're looking at heat that is stored in the soil, underground rocks, fluids in the Earth's mantle. So the heat really is coming in from underneath the Earth. Now, keep in mind, there are volcanoes that are around. So where there is geothermal heat, you can be sure that there's some kind of volcanic activity that's under the ground and it hasn't quite come up. Mammoth Lakes is an example of a place they do have a geothermal power plant there. If you go up on the Highway 395 north from Bishop to Mammoth Lakes, as you get to the exit, it is on the right hand side as you get to the exit to go to Mammoth Lake City. Okay. Now, so with the geothermal heat pump system, a lot of good advantages for it. It's efficient. It's reliable. Okay, it's environmentally clean. Okay, certainly cost effective to heat or cool a space. Now, this is where you get into hydrothermal reservoirs, of which the U.S. is the world's largest producer. Hot, dry rock that's there. We can use that to warm up water. Now, there's some good things about it, but there's also some downsides about it. There is a high cost of tapping these hydrothermal reservoirs. Well, wait, what do you mean by hydrothermal? Think of water that's under the ground, but it's heated up because of the mantle underground. Remember, when you're digging into the earth, it's going to get hotter there, especially in those areas there tends to be earthquakes. There's some kind of underground volcanic activity there. Okay, so that's some of the problems that you have. So when you have a house like this, before you actually build the house, you really got to put in your pipeline in there, and that takes time. Takes time, takes money. So your initial costs, your starting costs, are more. So this can cause earthquakes. You could have dry or wet steam geothermal reservoirs. Could they be depleted? Yeah, there's always that risk. It's costly. There's the risk you can run out. Okay, and it could create earthquakes when you're digging in because that area is not exactly the most stable. Another thing I would point out in the Mammoth Lakes area where they have the geothermal power plant, some of the trees that grow around that place are dead. Why are they dead? Because when they dug into the ground, the heat coming up from the ground, that's where you're getting your geothermal, caused the trees to die. Not burn up, just die. Okay? So when you look at geothermal sites in the United States, you have those areas where it's excellent areas. And if you notice, those are areas here in California where it is mountainous. Okay. And that's not really too big of a surprise here. And then, of course, all along here, you've got the mountains, you've got the Rocky Mountains here. as well. Okay, and then I mentioned about Yellowstone National Park here. You have a volcano that's under there that's liable to blow at any time. So that's it for that. And then, of course, if you look at the world, it's not too big of a surprise when you look at the United States, Central America, and South America. They are on one side of the Pacific Ring of Fire. When you go to the other side, notice the upper area here of Russia. Okay, you got some things going into China. You look at the entire region of Japan. What a surprise, because Japan is literally a series of volcanic islands. Hawaii, the Hawaiian Islands, are a series of volcanic islands. These islands were formed by volcanoes that came up from the bottom of the ocean. Okay, and again, you see some spots in Australia. And then here around Southeast Asia, you have some areas. Got some areas in Africa, got some areas in the Middle East as well. So when we look at good things versus bad things, advantages versus disadvantages, and that's what you guys need to know, all right? Good sides of geothermal energy: moderate net energy, high efficiency at accessible sites. Not every place is going to have this. You don't pollute like you do with fossil fuels. Low cost at favorable sites. The downside is there is a high cost, there's low efficiency unless it's concentrated and accessible sites. Scarcity of suitable sites. Again, you don't have that everywhere. Noise and some CO2 emissions. Yeah, you're not going to escape that. Okay, hydrogen. Hydrogen is a clean energy source as long as it's not produced with the use of fossil fuels, but it has a negative net energy yield. Yeah, we kind of talked a little bit about that. We look at hydrogen as a fuel. Again, when you have hydrogen with oxygen, H2 plus O2, okay, and let's balance it for the sake of argument, okay, you get, oh, excuse me, I'm sorry, water vapor, but you get a lot of heat energy as part of that release. That is an exothermic reaction. So, but it's very temporary. If you have a certain amount of hydrogen gas, you light it on fire, it go poof, and that's it. It's pretty quick. Okay, so you do need a lot of it. Cutting down the threats of global warming, right? Because you're not putting any greenhouse gases up there. You do have a fuel cell separates the hydrogen atoms, electrons from their protons. Some challenges that you've got with hydrogen. Okay, oops. Challenges. How do you get the hydrogen? Because chemically, it's in water. It's locked in the water and organic compounds. That's where you're getting your net negative energy yield, because you've got to put a lot of effort in order to get the hydrogen out of there. Expensive fuel cells are the best way to use hydrogen. Yup. And CO2 levels depend on what method are you producing the hydrogen. Again, if you're breaking down organic compounds, you are going to get some CO2 out of it. If you're breaking down water, you're not directly making CO2, but if you are using electricity to break down the hydrogen from the water to separate it chemically, which you can do easily with a battery and a couple of wires and a couple of test tubes in a cup. Okay, it wouldn't be that hard to do. So you can actually separate it. It does actually work. Okay, might give me an idea. But anyways, now some of the problems that you have with hydrogen as a fuel. Again, net negative energy yield. Production and storage of hydrogen. This stuff's flammable. Okay, it can go boom, and if it go boom, it's fast. Okay, we talked about hydrogen powered vehicles, prototypes available. Okay, can we produce hydrogen on demand? That's another thing. Getting the hydrogen isn't instant. It's not. And of course, larger fuel cells. Yeah, you guys are catching me when I'm yawning, okay? You get fuel cell stacks from it. Okay, trade offs for hydrogen, advantages, disadvantages. Okay, good things. You can make it if you got lots of water at some sites. You're not making CO2 if you're producing it from the water, but how else are you going to get the energy to produce it? Just a thought. Good substitute for oil, high efficiency. The downside is net negative energy yield, CO2 emissions if produced from carbon containing compounds. High costs require the subsidies. Yep. And certainly you need a storage and a transportation system. And I talked to you guys about the Toyota prototype vehicle. That is a very real thing. That if a hydrogen fuel cell has a hole put in it and you have an electric spark, you now have yourself one big boom and it's done. Okay. So, can we make hydrogen workable? We can take advantage of bacteria and algae that can make hydrogen by biodegrading organic material. That is a positive thing. Okay. But how much do you need? How quickly can we get this done? All right. So, using electricity from renewable energy sources to produce hydrogen. Well, hey, you could use wind turbine energy. You could use hydroelectric power to produce this energy, to produce the hydrogen. And those would be great renewable energy sources. Well, what about solar? Okay, and storage options for hydrogen. I think we can generate the hydrogen. I think our big thing is storing it safely because remember this stuff is flammable. Okay. All right. Transitioning to the future. Big thing. Okay. So looking at our last chapter, how do we go about in the future? Certainly improving energy efficiency, using different renewable energy resources. We also have to look at environmental costs and health costs for energy resources in their market prices. So, how do we create the policies? There's a hard way and a soft way. I'm not going to worry too much about that. The idea of using different energy sources. And I think it's really depending on what part of the country that you're in. Again, I've said it before. Southern California, wonderful for us to use solar power. But if you're in Chicago or New York City or you're up in Alaska, not so good. Okay? So if you look at Alaska, probably it'd be a great argument to use fossil fuels because that's pretty reliable. You can't, we can never eliminate fossil fuels at this point. We just don't have that capability. You're still going to use it. Natural gas is still the best choice. Okay. Well, of course, we need to improve energy efficiency. And this is just an idea that if we have all these different sources of electricity, that we feed it into a smart electrical system that's able to distribute the power to wherever it's needed. Now, I've got to point something out. If this works so well, why can't we have solar panels all over Southern California? And why couldn't we send electricity to places like Chicago or New York? Because we're generating lots and lots of electricity. Well, keep in mind, okay, we would need lots of cable in order to transmit that power. And the problem that you run into is something called the second law of thermodynamics, the entropy. We would be losing a lot of the electricity getting it from Southern California to New York City or Southern California getting it to Chicago. That's just the thing. How much would it get there? Probably not enough to make money. And that's where you run into another thing here. For a lot of these renewable energy ideas, if the idea is to make money with it, then you're in the wrong business because all these would fail literally in the marketplace. They're too expensive for the average person for what they produce. That's just the reality, guys. Solutions, again, improving energy efficiency, more renewable energy. I do agree with the idea. And that's it for chapter 16. And hopefully this time we will now have that fixed. And you got to see the notes. I'm sorry, guys. Take care, guys. I will see you the next time.